Ecological Highlights. This is episode 214. I'm Ben Marshall, and co-hosting, as always, is Tom Major. And, well, we've got an episode all about perhaps one of the strangest groups of reptiles. I'm not sure if anyone would even try and dispute us on that.
No, they're really weird. They're weird. They're weird little lizards with no legs. And obviously lizards having no legs is kind of cool. But yeah, these ones, they're just confusing little creatures which are sort of largely mysterious because they live underground. We're talking about Amphisbaenians.
Classic fossorial mystery. You can't see what's going on down there, so they could be up to anything.
They could be up to anything. We're kind of trying to pick apart what they get up to. We're trying to learn more about them. And this episode, we've got, an Amphisbaenian special, really. We've got a paper all about their kind of behavior and how they use smell to their advantage underground, which is quite interesting. And then we've got a brand new species of Amphisbaenian too. And these are disparate Amphisbaenians, showing that Amphisbaenians have kind of taken over the world. And actually,
in a sort of low down underground kind of way, yeah. I suppose you could class them as that.
But what's weird though is that they sometimes are at high altitudes, but then still underground.
So right now, despite being on the ground, they could be an Amphisbaenian higher up than you, is what you're saying?
Easily. I'm pretty much on sea level right now. So yeah, I'm sure most Amphisbaenians are probably higher up in the world than I am. But let's introduce this paper that's just come out. So this is by Martín Navarro-Castilla de la Concha, Cuervo, Barja and López, 2024. Heat-altered scent marks of males of a fossorial reptile still allow recognition by females, but lose information on male quality. And this was published in Behavioral Ecology and Sociobiology, the journal we come to quite a lot because it's all about what animals do and how they sort of socialize with each other. It's quite a broad remit. It's usually quite cool. And in this case, we're talking about the Iberian worm lizard. It also has other names. Some people call it the Mediterranean worm lizard. Some people call it the European worm lizard. And it's this species of reptile in the family Blanidae, so it's an Amphisbaenian.
Yes, the bland lizards.
It's horrible, isn't it? Blanidae. But the Iberian worm lizard is found in Portugal and most of central and southern Spain. So yeah, European species. And there's a few different names for it. In Portuguese, they call it cobra cega. In Spanish, they call it culebria ciega. And in Catalan, they call it colabreta cega. And all of those mean blind snake. So both Spanish and Portuguese names for this are, to do with it being blind and being a snake, which it isn't. It's a lizard. So strictly fossorial lizard, as we said. So it lives underground.
It's not a relative of your typhlops and Fred snakes sort of guys.
No, exactly. It's completely separate to blind snakes, despite Spanish and Catalan and Portuguese people calling it a blind snake. That's an old name. It does look like a snake, to be fair. It has no legs. And it spends virtually all of its time underground in sandy soils and beneath leaf litter. And they eat insects and insect larvae, which is pretty typical of these kind of legless reptiles that live underground. And they spend a lot of time under rocks.
To be fair to them, are there going to be many other prey types that are small enough for them to consume other than small invertebrates?
Not really. What else would they find under there? I guess potentially other snakes and lizards, but yeah, they're not massive, are they? So
I feel like they've got a reasonably limited sort of suite of opportunities there when it comes to prey.
Yeah, it's not quite the same as a supermarket. If you're just under a rock, you kind of got to make do with what's there. And you're right, it's probably just going to be insects and insect larvae. It's an honest living, that's what they do. And these ones are quite chunky, they've got quite short bodies, they're quite sausage-like, and the tail looks like the head, and like I said, no legs. So we've got these Mediterranean worm lizard, Iberian worm lizards, whatever you want to call them. They're going around underground in their little tunnels, which they call galleries, which I do quite like.
Galleries?
This word gallery.
Lizards, huh?
Yeah, just describing these little sort of tunnels that they go around in as galleries. It's a little bit romantic, that. Just imagining them perusing the galleries. But they communicate with each other in their own way. Obviously, they do have eyes, but they're not much good. They're kind of under scales and they're sort of largely, what would you call them? vestigial, I guess.
Well, and even if
leftover
they
from-
were decent, the lack of light in your fossorial environment is going to sort of undermine their use regardless. You could have the best eyes in the world, but if you're covered under dirt, good luck.
Yep, very good point. No light, no sight. That's what they say. So yeah, they're going around in their little galleries, their little tunnels, and they do need to find a way to communicate with each other, right? Because they can't exactly show off their special, they're not like lizards or something, flashing bright colours to show off their wares. They've got to leave little smells behind for their friends to find. And not that they necessarily have friends, but they do socialise in some way, and they communicate with each other. Maybe they have friends. We don't know enough about them. But they do communicate with each other. They use chemical communication. So this is animals sharing information via smells. And there's been a paper quite recently from this group, most of the same authors, and they found that females, so female Iberian worm lizards, preferred to settle at sites that had been scent marked by males compared to similar sites with either a female scent or without a scent. And they also found that the scent that comes from the males is different in terms of its attractiveness. So females like older or larger males, and they also like males with a better immune response. So if they have a strong, healthy immune system, the females can somehow detect this from the smell of the male, and they're more likely to spend time in the vicinity of that smell than a male which has a less good immune response.
I think this is kind of a really critical aspect of it, isn't it? Is that they've got evidence that these scent markings aren't only to do with preference, but connecting that preference up with particular traits in the males. It has a wonderful setup of like, okay, now you can sort of apply a little bit of almost motivation to mate choice in this scenario because you know what traits they're connected to. And logically, sort of natural selection sort of perspective, it all tallies up and it all makes sense that you're going to be, they're going to be selected for those ones with better immune systems, potentially larger, that might be indicative of better at finding resources, those sorts of things. The age thing might be a proxy for sort of survival and success as well. So it all nicely agrees, and I think that sets up a really good context for this sort of follow-on study.
Yeah, that's it. They already have the basic information about the fact that females show a preference, which then allows them to kind of catapult themselves into this like slightly more advanced analysis. And so the kind of pretext of this is that when animals communicate, they're always trying to maximize the information that's conveyed if possible. And that's not necessarily to say that, I'm sure the individual animal itself is trying to maximize the information, but also like evolutionarily, they should be trying to communicate in a way that's going to be sort of decoded by other animals. And in this paper, they use at least good enough, yeah. And they use the example of anoles in this. So these are lizards which communicate with sexual signals using their dewlap. We've talked about that quite a bit. So this is a sort of flap on the chin, which is used as a visual signal. And these signals in anoles have evolved to work best in the light conditions that the anoles hang out in. So evolution has kind of tailored them to work best where the anoles actually are. And in theory, the same is probably true for these worm lizards who have these kind of chemical signals giving off, communicating with each other. Well, if they're leaving these smells, they should hopefully work well at the kind of temperature and other factors where these worm lizards are found.
Yeah, there's loads of examples of this. I mean, we've brought up the like frogs changing their calls depending on like ambient sound and things like that. All these are, I mean, I think that was less an evolutionary change and more a sort of plasticity change. But there's loads of examples of this. Like you need to be cognizant of your environment, either genetically or behaviorally, to make sure you can communicate through whatever noise or sort of background interference you've got to handle.
Precisely. So that begs the question, what happens to these lizards' smelly signals under the ground if the Earth gets hotter for some reason? Does extra heat affect the smelly signal, or does it not really matter? Yeah.
Be that climatically, be that because of drought, be that because of maybe a fire or something along those lines. Sort of general sort of climate shifts in Iberia towards warmer, more sort of fluctuating highs and lows in temperatures potentially.
Yeah, absolutely. And so the way they did this was they collected up a bunch of these lizards and they got their smells off them by putting them in tanks and putting them on. They sort of put they like hiding under rocks, right? So they put like a little tile in the tank, and the males dutifully went under there and left their smell. And they basically compared how females reacted to the smells of males that had just been kept at the same normal temperature, like in the 20s, or smells which had been heated to 30 degrees Celsius, 86 Fahrenheit. So
this sort of drought scenario is sort of what they're getting at, right? Like hot summer drought scenario.
Yeah, they basically said that, this isn't some wild hot temperature that would like never happen. If there was like a super drought or like you say, a heat wave, which obviously getting more frequent, then 30 degrees is like a conceivable temperature. They didn't bake them in an oven. Like these are temperatures which the smells could realistically have to sort of tolerate,
handle,
or at least
handle.
And so they talk about the sort of female preference, and the way they determined this was by putting females into boxes which had 2 hiding places, and they were comparing either sort of control without a smell to just the smell of a male, and they were also comparing the smell of a male and the smell of a male that had been heat treated.
Yep.
And they definitely spent more time.
10 hours, I think it was. They checked on them every hour, and over the course of 10 hours, every hour they'd check what side the female was on, and then it was a sort of like score out of 10, determine a sort of preference out of 10 in that sense.
Yes. And so, essentially they're looking to see whether females have a preference for these male scents and whether or not it matters if they got hot. And as it turns out, females did prefer hiding places with male scents, regardless of whether they'd been heated. So they preferred male scents to non-male scents, regardless of heating. But the ones which were not heated had more time spent under by the females. So the ones without heating seem to be slightly more popular than the ones which had been heated. And so, they talk about why this might be, and they do mention that the main compounds in these scents, so the scent of the males comes from these like pre-cloacal and cloacal secretions. They have glands which are sort of making this smell. And they contain mostly 2 steroids, are the 2 like main ingredients, cholesterol, methyl, and cholesterol. And these, they say, have really high melting points, so they may be able to stay in the environment sort of unaltered. So the 2 main components are probably likely to be unaltered, but then there's a host of other smaller components which could change, which the females may be attuned to.
Yeah.
And so, so less heated, the smells that hadn't been heated were preferred, suggesting something happens to the smell when it gets heated. And what was interesting was that females preferred, again, as they found in the former study, they preferred males that have this really high immune response, likely indicating a kind of healthier state. But when they heat treated the chemical signals, they seem to lose this information on the male's immune response. So the females
you had this nice relationship, higher preference with higher immune in the ambient scenario, but then with the warmed sense, that relationship essentially disappears, and you don't see them showing higher preference for the high immune response male sense, which you would expect. And the only difference there is the heating treatment. Yeah.
Yeah. So this heat, this additional heat, even just up to 30 degrees, seems to affect the female's ability to make mate choice decisions, potentially. They're not as able to determine what's a healthy male.
Assuming that sort of better immune response is a better mate, which I think is a pretty safe assumption.
I think so. Like, if I was picking a mate, I wouldn't want someone who's ill all the time. It'd be so annoying.
Right. So it seems kind of like a slam dunk, doesn't it? It kind of seems like this heating is sort of sabotaging their ability to pick a healthier mate.
Exactly. So bit of a problem potentially for these females. And even short exposure to this unusually high temperature could harm the chemical signals that these male Iberian worm lizards produce, which might change the information they use to pick mates.
Yeah.
We don't know whether the animals...
because it's still there and the preference is still there. It's that like secondary information that's being lost, which is really intriguing. So it's not like completely just destroying the sense.
Yeah, and that's why it's so cool that they went to the lengths of actually determining the like ability of these males to like fight off disease. And the way they did that was kind of cool. I'd never heard of it before, but it's this like injection that measures immune response. They basically inject them with like it's called phytohemagglutinin, and it's like some compound from plants, and it makes you swell up. Your body basically produces an immune response to it, and the more they swelled up, the more they decided they had a strong immune system. You can do it. They do it with infants as well. Like, it works on people.
Sounds fun.
I want to try it out, see what mine's like. Then show Maya and be like, look at this. Look how immune responding I am. Wow. She'll love it. And then, we basically don't know whether the animals can adapt to this change in being able to determine their chemical signals. Maybe they'll decode something different. Maybe it will just relax the criteria for how they select mates if it gets hotter. There is an example of this, actually, which they mention in the paper, of three-spined sticklebacks. Basically, if there's like really nutrient-rich water where eutrophication has occurred, it makes the vegetation really dense, and the three-spined sticklebacks just can't really see anything. It's too dense. And what they found is that, in those environments, normally they have quite strong mate selection based on the belly of the male being red. But if the water's too cloudy or there's too much vegetation, the females just don't have such strong mate choice. They just
what
they don't
use
have
is
the
a visual
ability to
signal in
differentiate.
a place that you can't see a visual signal, right? It's exactly what we were saying with the communication at the beginning of the chat. Yeah.
So it might just be like that. It might be that they lose this ability over time to determine it, or maybe they'll find a different way to do it. But anyway, it's just this tiny little system of females picking males under these rocks, and you just never think it was as complicated as it is. But they really are thinking about a few different things.
Wise worm lizards of the Iberian Peninsula.
They are wise worm lizards. And I think we should respect them, even though they look like weird little bumpy sausages. So, shall we move on to our brand new species of Amphisbaenia?
We absolutely can, yeah.
Okay, so this one is by Ribeiro, Santos, Martins, Oliveira, Graboski, Barbosa, da Silveira, Benício, and Vaz-Silva, 2024, a new four-pawed Amphisbaenian from the north of Espinhaço mountain range, Brazil, published in ZooKeys. So we're traveling. Look at this thing. We're traveling from Europe all the way to eastern Brazil in the Caatinga. Caatinga is this kind of semi-arid tropical vegetation, and it's also an ecoregion characterized by this vegetation in Brazil. So it's kind of semi-arid, dry. What does the habitat here look like? It looks kind of, a bit sort of scrubby. Not like a forest. Not what you'd think of when you thought of Brazil, at least not, I immediately think of the kind of Amazon vibes, but this is very much like a sort of scrubby, sort of lower vegetational style.
Right. Where, being fossorial might be an advantage, because if you don't have that much cover above it.
Yeah, well, they quite like sandy soil, don't they? And
easy to
certainly
dig for
the pictures. The pictures they've taken in the paper certainly look like nice, sort of quite sandy soil. Yeah, loose, burrowable. And they've described this new species from this area, and they've called it Amphisbaena amethysta, so amethysta refers to the mineral amethyst that is a type of quartz, and also the name of the region of the type locality, Brejinho des Ametistas, sorry about the pronunciation, which is a district south of Caetite in Bahia. So this region has basically been an amethyst mining center since the beginning of the 20th century. So we've been taking amethysts out of there. And this species is endemic to that area, so they've named it Amethysta. So
solid name.
Named for the beautiful minerals on which it burrows.
So we can dig into the name a little bit more, because we know where the word amethyst comes from. So, like you said, amethyst, quartz, it's made purple with like iron and other irradiation sort of stuff that makes it purple. The word amethyst, apparently, according to good old Wikipedia, the first bit is not, from ancient Greek not. The latter part is to intoxicate, from modern Greek. And this all comes, apparently, if Wikipedia is to believe, amethyst as a protection against drunkenness or intoxication. So if you were to drink out of a amethyst vessel or cup or something, it would protect you from being intoxicated by the alcohol you were consuming.
Really? Why would you be drinking alcohol if you didn't want to be intoxicated, though?
Presumably, if it was really trashy alcohol that would have bad side effects if you were.
Right, so maybe you're like,
This is also the era, this is ancient Greek stuff of watering down wine and stuff like that. So,
right, okay.
They're not part of the UK binge drinking culture, is what I'm trying to get at.
Power to them. So, I don't know what else there is really much to say about this thing. It's quite pink. It looks very pink. And these Amphisbaenians, they have these like their
doubling
scales
up on
are
the sort of like purpley hue
purpley amethyst
name thing, which I think is great. Maybe if you hold it, you don't get drunk. Who knows?
Yeah. If in the paper it says they're brown and pink, but the pictures it just looks quite pink. And they look annulated, right? They look like they're covered in like rings because like a Sicilian, because they have these like really big, almost rectangular scales that go
very regular rings. Scaling. Yeah, almost like tiling.
I think that's
almost.
Part of what makes the head look weird is that the head has different scalation, so the head kind of looks a bit, it's not naked, it's covered in massive scales, but it looks a bit naked compared to the body. It gives them a weird.
And they're about 23 centimeters long.
Right on. You ever seen an Amphisbaenian in the flesh?
Trying to think. I don't think I have,
I never have, ever.
Certainly not in any species. It's certainly not like worked into my brain. Yeah, no, I don't think I have.
No.
It's a shame. A goal for the remainder of my life.
I think we can accomplish that. We'll do it together. We'll find an Amphisbaenian. So, this species is endemic. Little trip to Brazil. I mean, we could probably just go to Spain. It'd be easier.
Okay.
But I'll be happy to go to Brazil. Yeah, let's go to Brazil. But yeah, this one's endemic to this Espinhaço mountain range. And it's from quite high altitude, 1,000 meters above sea level. As we said, these things are at high altitude. And it only occurs over an area of 38 kilometers. I should presume that's kilometers squared, don't know. But yeah.
So almost certainly vulnerable or worse then. Because that's tiny.
Yeah, probably. And it seems like a lot of these Amphisbaenians have these kind of like quite narrow ranges. They're sort of restricted to high altitude areas of particular mountain ranges. So I would assume that this kind of scrubby vegetation is only at higher altitude.
It kind of tracks because I can't imagine they have the greatest dispersal abilities.
Well, they have to go underground.
Yeah, take them ages to go anywhere.
Yeah, and if they bump into a rock, you got to turn around. Forget it. But there we go. That's our new species of Amphisbaenian. And yeah, like you said, it would be nice to try and find one sometime. I've still never seen a Brahminy blind snake.
Well, you don't have to go anywhere for those. They're all over the world.
There's probably some in Kew Gardens, aren't there?
Yeah, check your flower pots.
Yeah, I don't think
Kew Gardens tip all their flower pots upside down.
They don't take kindly to people digging up the plants at Kew Gardens.
Well, that's only if you just got to do it quickly at night time.
So there we go. We got 2 papers about these weird little worm lizards, and yeah, I'm still slightly shocked by the fact that they have quite so much going on in terms of what they're
Such
smelling.
Rich social lives. I think it's wonderful. I'm amazed the amount of information people have managed to sort of pull out from a fossorial species.
Yeah, that's what's so cool about it, because these fossorial ones particularly are super mysterious.
Complete mystery. Yeah.
I really like the title. The paper where they first found that the Amphisbaenians preferred like the scent marks of bigger males. The title was Blind Date. Female fossorial Amphisbaenians prefer scent marks of large and healthy males.
That's pretty good.
It is a blind date. They are on a blind date. But there we go.
Excellent.
Have you got any other business?
I do not have any other business for this week. No.
No, neither do I. So I think that all that we need to say is, first of all, thank you to our patrons. If you want to support the podcast, you can. Patreon.com/herphighlights. We are on social media. You can find us on TikTok and Instagram at herp_highlights. I'm Tom_E_major on Instagram. Yeah, if you want to get in touch, ask us a question, make a correction if we've misrepresented something, please let us know. And until next time, thanks for listening.
Thanks for listening.